Hey everyone, welcome back. This is Chapter 5, Lesson 1, using transformations to graph quadratic functions. This is going to be Part A. This lesson you're going to learn about horizontal and vertical transformations. The objectives for today's lesson, you're going to be able to transform quadratic functions. You're also going to be able to describe the effects of changes in the coefficients of the equation y equals a times x minus h squared plus k. Your vocabulary for today is going to be quadratic function, parabola, vertex of a parabola, and vertex. In chapters 2 and 3, you studied linear functions of the form f of x equals mx plus b. We also think of that sometimes as y equals mx plus b. And sometimes we see a linear equation that's written like this, x plus y equals a constant c. All right, and a quadratic function is a function that can be written in the form right here, where a can't equal 0. We've also seen quadratic functions written like this. F of x equals ax squared plus bx plus c. So, the difference is in a quadratic function, the variable is always squared. So we always have our variable squared. Notice in our linear equations, our x is raised to the power of 1. But in a quadratic equation, our x is raised to a power of 2. And that's what makes it a quadratic function. So the table shows the linear and quadratic parent functions. In the linear parent function, this is the most simple function, f of x equals x. So when x equals -2, y equals -2. X equals -1, y equals -1. And when we plot all these points, we get one straight line. Okay? For the quadratic parent function, it's f of x equals x squared. All right, and so we could make a table and just fill these in. When x is -2, -2 squared is 4. When x is -1, -1 squared is +1. X equals 0, y equals 0, and so on. So when we plot those points, we get this shape, which is called a parabola. All right, as with other functions, you can graph a quadratic function by plotting points with coordinates that make the equation true. Try this example. It says, make a table, plot enough ordered pairs to see both sides of the curve. So we're going to use this graph here, x squared minus 4x plus 3. So first of all, we're going to make a graph or a table. And I've already made it for you, so let's just take a look at that. So basically, we just, everywhere we choose some x's and fill them into our equation. So x squared when x is 0, 0 squared minus 4 times 0 plus 3. So when x is 0, y is 3. So we just have to plot that. 0, 3, and then the same thing when x is 1, we fill it out, y is 0. Plot that point. When x is 2, y is -1. Plot that point. X is 3, 0, and x is 4, 3. So I've plotted enough points here that I can actually see what my parabola is going to look like. So there it is. Here's another one. I want you to try this one on your own. So turn the video on pause for just a minute and see if you can do this one. And you might want to notice that I've already got a negative, so our parabola is going to be going this way. So when you try it on your own, see if that's what you get. All right, so it says make a plot and plot enough ordered pairs to see both sides of the curve. So let's do that. Here's our table. I went ahead and put them all in here for us so that we could just move on. So when x is 1, y is -15, and it's way down there. 1, -3, 3, 1, 5, -3, and 7, -15. So there's your point. So now we have enough to see what our parabola is going to look like, and it is indeed going down. All right, so I hope you were able to do that one on your own. You can also graph quadratic functions by applying transformations to the parent function. such as f of x equals x squared. That's our parent function. Transforming quadratic functions is similar to transforming our linear functions. So as you can see, if you want to do a horizontal shift, we're dealing with our x. So x, the shift, h, is going to get snuggled up inside our x when we're shifting left or right just in the x. And when we're doing a vertical shift, we're going to be dealing with the y. And remember, just like when we would do linear functions, we would just add it at the very end or subtract. An example, use the graph of f of x, the parent function, equals x squared as a guide. Describe the transformation and then graph each function. All right, so what is the first thing we want to do when we have our equation here? Well, first we want to sketch out what the parent function looks like. F of x equals x squared. Now you could actually do a table or a chart to see that, but I've done it for you. If you'll remember, we should have a dot here and x equals 1, 1, and x equals negative 1, 1. And same with our 2. With our 2, x, because 2 squared is 4, and negative 2 squared is also 4. So we can keep on going up our chart. So here's our parent function. I want you to always graph your parent function first, and that's a pretty easy function to graph. Okay, now the next thing we have to do is identify our h and our k. Okay, well, let's identify that then. Remember, this is our formula, h and k. So it says identify h and k, and here's our h. That's going to be our negative 2, and here's our k, which is 4. So what does it say to do? It says from the x, we're going to go 2 places. Okay, so x is going to move over 2. So original x was here. We're going to go over 2 to here. And then it says x, the y, is going to go up 4. So let's go up to 4. All right, so 2, 4. So now what we have is, let's plot our new graph. It's going to still be the same parent function, just moved a little bit. All right, and here it is. So because h equals 2, the graph is translated 2 units right. All right, because k is equal to 4, the graph is translated 4 units up. Therefore, g is f translated 2 units right and 4 units up. So that's exactly what we did. Over 2, up 4. All right, and that's where our new parent function is. All right. Let's look at another example. This time we're going to use the graph f of x equals x squared, which is our parent function, as a guide. And then we'll describe the transformations that take place and graph it. So the first thing we want to look at is our, we want to identify our h and k. So let's look at what our formula looks like. Our formula says x minus h, but over here, it says x plus h, so we need to change that x plus 2 to be in our exact format. And all we would have to do then is, instead of saying x plus 2, we could also say x minus a negative 2. And that way, you can see that we are now in this format, the vertex form. So now we can identify our x and h correctly. And so our h is a negative 2 and k is a negative 3. And here's our parent function, the very first thing we want to do. And now let's do this together. It says x is going to go negative 2. All right, so we have to move our x negative 2 in the negative 2 direction over that way. And the y is negative 3. So we're going to come down here, negative 2, 3. All right, so our new function is going to be, the vertex of our new function is going to be down here. Let's take a look at that. Okay, there it is. And because h equals negative 2, the graph is translated 2 units to the left. Because k is equal to negative 3, the graph is translated 3 units down. Therefore, g is f translated 2 units left and 4 units down. Here's an example for you to try on your own. Put your video on pause and give it a try. Okay, welcome back. So the first thing we want to do is to identify our h and k. So let's write our equation down again. Let's take a look at the vertex form where we have an h and a k, and we can make some decisions here. So notice that our h is snuggled up with our x inside our parentheses. But in our question, in our problem, there's nothing in our parentheses here. So we actually don't have an h. All we have is a k. All right, so first of all, let's just take a look at our parent function. All right, and now all we're going to do is just move our parent function down 5 units. So it's actually down here. So here is our new equation, or our new graph. It's just the same parent function, but it's just been pushed down 5. All right, because h is 0, the graph is not translated horizontally. Because k is -5, the graph is translated 5 units down. Therefore, g is f translated 5 units down. All right, we have one last equation for you to do on your own. It says graph this equation and use the parent function as a guide. So go ahead and get started with that. Turn the video on pause and then come back when you're ready. All right, I hope you didn't find this one to be too challenging. The first thing we want to do, as always, is find our h and our k. And when we look at our formula, we notice that x is snuggled up here with our h, but here it's a plus and here it's a minus. So we need to rewrite it so we have a minus there. And here it says plus k, but I actually have a minus. So I want to rewrite my equation so it's exactly like my format. And now I have redone that, and so I have x plus, instead of x plus 3, I have x minus a -3. So I can see that my h now is going to be -3, and my k is going to be -2. So there's that, and then we want to graph our parent function. And so here is our parent function. This is going to tell us that we're going to go -3 horizontally and -2 vertically. So let's go ahead and do that real quick. We'll go ahead and graph it. And so you can see that I went over 3, 1, 2, 3, and down 2. So here's where my vertex is. It was over 3, down 2. All right. So, because h is -3, the graph is translated 3 units left. Because k equals -2, the graph is translated 2 units down. Therefore, g is f translated 3 units left and 2 units down. Yay! So recall that functions can also be reflected, stretched, or compressed. All right, but we're not going to do that in this video, so you could celebrate. And that's the end of this video for right now. I just put this picture in here with a Bible verse. It says, I have set my bow in the cloud, and it shall be a sign of the covenant between me and the earth. When I bring clouds over the earth and the bow is seen in the clouds, I will remember my covenant that is between me and you and every living creature of all flesh. So, when we dwell on God's majestic parabola, we're always reminded that God always keeps his promises, and also maybe reminded that God's favorite subject might be math. Anyway, I hope you guys have a great day, and I'll talk to you soon. Bye now.